First and foremost, thank you to the club for giving me the opportunity to talk about a very complicated subject. So I'll do my best to try to propagate the message in simplified manner. So let me share my screen and we'll get started. Today's presentation, I came up with the name is Advancement in AI because the growing growing emergence of AI, it's very important for us to understand that what are the advancements we made so far, what's the history behind this artificial intelligence, and what's the future looks like. So I'll dive into that in a different various topics of the AI. So let's go get started. Before I talk more about AI, I want to introduce myself to you all just in my own way. And Mark already covered a little bit of introduction. I wanted to add a little bit more to that. As I am Illini grad since 2021, it's been an honor to know this Houston Illini Club probably since last year. And with my professional experience in the finance, insurance, and marketing industry, I'm still making a lot of trying to make a lot of opportunity for the new students and also for the communities on LinkedIn to help them know more about AI, because this is something it's still quite evolving. We don't know a lot about it. To contribute my my enthusiasm, I wrote a research paper on AI a couple of years back, and I'll talk more about that research paper in the later section of this presentation. Apart from my research authorization, I'm also I'm also an AI project instructor at online education organization at Coursera. And also I have a little bit of side gig, which I do it mainly for my passion and interest. I'm a YouTube and podcast host for channel Data Science with Sam. So any of you are interested to know more about data science or AI, feel free to listen to some of the the podcast that the episodes out there on the channel on the Apple and the Amazon Music platform, and also feel free to watch some of the YouTube vlogs that oriented towards data science and AI. Now, in today's presentation, I'll cover 4 topics. I'll start with what is generative AI, because this is a very rapid buzzword that's been kind of going on for the last couple of years. A lot of people asked about what is generative AI. So I'll touch upon that at the beginning of this presentation. And in the later section, I'll talk about natural language processing. Natural language processing is one of the foundation of the generative AI. So I'll provide some sort of a historical background of how this technique started and how it translated into generative AI in the last couple of years. Demystifying large language models. There's also some related technique that we are currently using as a backbone of generative AI. And towards the end, I will give you a little bit of insights about image analytics. This image analytics is also another important pillars of AI that people are getting into, because that's image analytics is helping us to interpret the visual data and also helping the healthcare industry in doing a lot of medical imaging and a lot of other face recognition stuff. So the first topic is, what is generative AI? So in simple terms, I would say generative AI refers to a new AI technique that can generate new content from text, images to music and more. For example, the generative AI term wasn't very familiar to the masses before November 2022, when ChatGPT was first launched by this company called OpenAI. People started talking about this generative AI stuff. What is this generative AI? It's merely something like you are asking the computer to create something new for you, something that's never been you've seen before. Like, for example, if you see this picture on the left, I asked ChatGPT this morning that, why don't you write me a poem about fighting Illini, our football team? So it wrote a very nice poem that probably we can use as a chant in our next Illini Club watch party. On the right side, I asked ChatGPT's imaging platform called DALL-E to give me a nice picture of the Illini campus from its imaginary thought. So this is more of like something that never happened before, before the advent of generative AI. Computer always do something what we instruct them, but they never came up with something new, a brand new. So this generative AI took us to a different level of the artificial intelligence innovation paradigm. Now, after launch of the ChatGPT, a lot of other companies like the big techs like Google and Meta started joining the race. ChatGPT, the OpenAI started the race, but they don't want it to kind of like, be the only company to do that. So Google and Meta started owning their own platform. They started coming out with their proprietary models like Google Gemini, right? Their new the Gen AI is becoming a very pivotal in the sense that it started showing us that how generative AI is being very influential in the technology paradigm and how it can reshape the competitive race between big tech companies. I guess a couple of days back, Meta launched their new Llama version model. Google is still working on building or enhancing their Gemini platform. So it's just like every morning you wake up to a new AI news, and God knows how long this race will be going on. But this is a very fascinating time when we see all these technology companies are fighting with each other to see who can develop a better generative AI platform. Now, before I talk more about this generative AI, the one thing I wanted to tell you guys about that, what's the difference between this generative AI and the traditional AI? Because artificial intelligence is not a new thing, okay? It has been there like even 30, 40 years back. But what changes that, why we started using this new term generative AI on top of what we already achieved in the artificial intelligence space. So I'm gonna give you a few use cases that we already achieved in the traditional AI space, and then how generative AI was a little different from that. So talking about traditional AI, as you can see on the left side of the table, there are 4 use cases that I wanted to focus on. The first one is predictive analytics. So what is predictive analytics? It was nothing but determining the future performance based on current and historical data. Like different organizations, whether it's a stock market prediction or sales growth prediction or any sort of other prediction that align with your business strategy, it falls under these predictive analytics categories. Companies hire so many data scientists, AI engineers to build a predictive models or analytics platform that will help their business to kind of like predict the future outcome. Similarly, the next use case is fraud detection, which is very, I would say, salient factor, especially for the banking and finance area. What they want to do is like they wanted to kind of like analyze or identify some of the fraudulent activities and build a model that can help them to tackle those frauds. Because in the banking and finance, we always get hit by fraudulent claims, fraudulent transaction and stuff. So AI started helping the banking and finance industry in the last 10, 15 years to do all this kind of fraud detection stuff. The third very key use case in terms of traditional AI is personal recommendation. If you go to Netflix or if you go to like Amazon channel, you always get some recommendation of movies or something you already purchased, and Amazon is giving you a recommendation based on your purchase records. So this kind of personal recommendation is possible because of the underlying AI models that Amazon or Netflix or other companies develop. The fourth key factor is business process automation. With the help of traditional AI, we're able to build some of those data quality check or some of those automation process that help the companies to drive their operation process in a more faster way, and that help them to bring more efficiency in their overall operations process. Now, on the right side, some of the generative AIs, which kind of like not fit in the traditional AI realm, are started coming up. Like, for example, automated content creation. So in the marketing industry, we have marketers, we have social media writers, they constantly create contents. Now, generative AI influencing their work, generative AI helping them to build a content or like a blogs or some sort of a social media articles in a more faster manner. It influencing their writing skill is also helping them to come up with a precise paragraphs within like a fraction of seconds. The second is AI generated art. As I showed at the beginning of this presentation, that I came up with that nice little like imaginary art from DALL-E. So some sort of like AI generated art will just help the artist or even any sales and marketing company to come up with the content in a more easier fashion. Automated content moderation, it's similar to like automated content creation, helping the social media teams to kind of like, develop social media contents in an efficient manner, and they can also roll out to them on the social media platform in an easier way. One quick example on that is like if you write a post on LinkedIn, sometimes you will see that LinkedIn's giving you a recommendation to rewrite that sentence or rewrite the paragraph using AI. So those kind of automated content and automated moderation are only, start becoming like, useful with the help of generative AI. Before the generative AI phase, we never actually had that opportunity to kind of like influence the writing or any content creation strategy or content creation practice on the social media platforms. And the fourth, use case of generative AI, which is not very relevant to a lot of industries, but this is something started slowly. It's called synthetic data generation. Especially in the banking and the finance area, we do have a restriction to, we have like a data unavailability issues because some of the data are restricted due to the privacy and other reasons. But most of the cases, those data unavailability issues create a lot of problem in terms of building a data science model or doing some algorithmic work. More data always influence a better prediction. So in this kind of cases, synthetic data generation could be helpful because here what we are doing is we are utilizing generative AI algorithms to build a data set that looks like the original. So those data sets, the synthetic data, can be used for further analysis and research purpose, and helping the company to not spend a lot of data or not navigate through those data privacy or data security concern and get data through just a computer based algorithms. So these are some of the use cases that helping generative AI to go to the next level that traditional AI wasn't able to achieve in last 20 years. Now, before I move on to the next step of the natural language processing, I want to see that if I have any question from the audiences. Okay, I will take the silence as no, and I'm going to move forward to the next one. The next topic is the natural language processing. So what is natural language processing? It's kind of like an AI technology that's give computer the ability to think about language, think about like, how human language been formed, how you can talk like a human, or how even you can process the human language. Before the concept of NLP, there is no way, a machine would be able to understand that NLP is possible, or you can interpret that, manipulate, or even comprehend the language. So NLP is, I would say, one of the key milestone in the AI innovation history that helps the computer to start utilizing human language, process it, and do something with that kind of take our AI innovation to the next level. Now, when it comes to evolution of NLP technology, we have seen that the NLP technology started from a simple text processing, and then it went up to like a different kind of processing, like sentiment analysis or different kind of stuff. Now, when I talk about the natural language processing and how some of the key breakthroughs happen in this natural language processing area. So I want to take a step back and I want to just go over the history of natural language processing, like how it started and how it kind of evolved. So this is a pictorial diagram of the timeline of the history of NLP. I'm not going to go into the much details, but I'll try to give you a very basic overview. So it started back in 1950s when the American Professor Noam Chomsky publishes a seminal work called syntactic structure. So this syntactic structure is kind of like laid out a theory that the transformational generative grammar. So what Chomsky tried to prove that the grammar was a mathematical system with precise and finite rules. Means, like you can basically construct a word and transform it into a mathematical formula or a mathematical vector. So this was a very groundbreaking, research or theory in the field of NLP, because it gives computer the ability to start understanding the language. Because for a computer, to understand the human language, it's very important for the computer to transform it into a mathematical formula stuff. So Noam Chomsky's, like these publications, like started taking the NLP, started actually kind of like starting the foundation of natural language processing technique. So in the early stage, back in 1950s, this whole concept of NLP was mainly rule-based system. Here at that time, a lot of linguistic professor and computer scientists, they used to handcrafted grammatical rule to kind of, and dictionaries to facilitate this kind of language processing work. I don't know very much about that, but this is one of the kind of like the basic backbone of NLP that often we overlooked, but that's where the thing started. Now, fast forward in the late 1980s, what happened is that some of these new architecture or neural networks models started coming out. The computer engineers started building some of the statistical approach to understand the language in a better way. Like, for example, they started utilizing some neural networks or some hidden Markov model to understand how the languages are interact with each other, how the sequence of words are correlated with each other. Then fast forward in early 2000s, we started seeing more advancement in the AI area. We saw that we witnessed that there are emergence of new AI models in the area of deep learning and neural networks. So this neural network and deep learning concept are nearly becoming pivotal in the natural language space, because it's giving, it's started giving natural language processing an idea of how we can start with the different kind of language process. So now in the early 2000s, when we started having all this kind of like what to take and encoder decoder architecture and stuff, one thing was always prevailing is that how we can get those the data, how we can process those deep learning architecture, how we can process the data in this deep learning architecture and synthesize it and provide that output. So that was always been a challenge. But this large language model innovation actually took us to the next level. So the large language models is more of like I would say the advancement of the NLP technologies, and we are still working on it. Now, in our current everyday life, we have seen how voice assistance, sentimental analysis, or some of the language translation work are being influenced by the large language models. Now, let's go to the next stage to understand that how all this process initially started. Now, as I previously mentioned, that when we build when we started this natural language processing concept, the idea was to transform a word into a mathematical vector space. And using the mathematics or using the cosine similarity and other mathematical formula, understand the linearity between the two words. Like, for example, here in the word embeddings, if you see that there's a simple example I want to demonstrate here is how the word mathematics and statistics similar to each other, or how the word tiger and lion similar to each other. So these are some of the word embeddings that AI models started performing, and especially when it comes to natural language processing. There are two main word embedding methods AI models started implementing. So the first one is TF-IDF. It was mainly to measure the importance of words in a document, and then that technique helped the computers to understand the content of a document and prioritize the most important terms. Like, for example, and when an AI model goes through a paragraph, it sees a lot of different words there. Now, which word is most important and which word comes often in that paragraph will be picked as the most important word, and that is something model use to kind of like predict the next wording. Similarly, there's another word embedding methods that became very popular. It was called word to vec. As I mentioned that the numerical representation of words became very trivial to get success in the natural language processing area. So this technique not only helps computer to understand the relationship between words, but it's also allowed them to perform like a different kind of text classification machine translation once we understand the relation between two words. So here's a simple example that I try to kind of like share here to elaborate more granularity about the words, how the word to vec concept usually come across. So think about there are like three different sentences here. The first one is the quick brown fox jumps over the lazy dog. Second one is I love playing with my dog in the park, and the second one is the dog is very friendly and loves to play. Now, the basic concept is that the word to vec model started training on these three sentences. The model learns about the word embeddings. The model started learning about the relationship between different words in those three sentences using a vector representation. And once the training is done, then the model will provide a vector for each word. Like for example, the word dog might be a random three-dimensional vector will look like that. Okay, again, I don't want you to like understand all the mathematical part. This is just for an example, like just consider that the word dog is more of like a vector or some sort of a mathematical notation. Now, once the AI model construct a vector correspond to a word, then it started performing some sort of a similarity measure. So there are tons of similarity measures. There are cosine similarity, Manhattan distance, or something like that. So those similarity measures will determine that what's the similarity between a word dog and a fox. So based on that similarity, the model usually draw the analogy. Right. For example, if the model somehow predict that dog is to bark, then as cat is to. Like if dog word is equivalent to the word bark, then what would be the equivalent word to cat of the same name? So the resulting vector would come up as a meow. So this is some sort of like I would say like word embeddings or mathematical techniques that the AI model performs internally to match the words with their corresponding words based on the similarity measures, and that helped the model to predict how the relationship will be constructed. Like if we definitely if we ask the model to create a sentence based on the dog and bark, then based on the similarity measure, the model will create the sentence and probably give us something like the dog is barking at the night. So this is very like I don't want to go into much technical details, but I hope this will give you an idea of what usually happens in the model range, especially from the mathematical standpoint, because this is the main foundation of natural language processing, where they are constructing sentences based on the correlation between words. Now, once we created the word to vec model, the natural language processing field started emerging. They started growing. People started using word to vec model for different natural language processing work to see how it can help them to perform text classification, document summarization, all kind of stuff. However, there is a limitation in those models. Those models were probably kind of like applicable, or they work well when the sentence is not so long, but when the sentence started forming very longer, and when you need to kind of like summarize something which has like more than 1,000 words and like a paragraph of stuff, they started the AI engineers started seeing some sort of a limitation there. So there was no particular like a technique at that time before 2017 that could address that. However, back in 2017, there is a real breakthrough came in that area when Google launched it published a paper called "Attention is All You Need." So they came up with a technique which is they called as like an attention mechanism. On the left side, I kind of like put down the architecture of that again, just for people who are interested to know about the architecture or something. I would also recommend you to kind of like, go to the link, just go through the link and watch the, just read the paper and just to get an idea about the transform attention mechanism. But in a nutshell, this attention mechanism is nothing but allowing the AI to kind of like, pay a close attention to not only the words, also paying close attention to the location of the words. For example, here are two sentences. I love eating apple. And the second one, I work at Apple. In the previous, foundation model would probably consider those two words as like a similar vector. So in that way, it will be kind of like a misleading because one is more of like using as like a fruit, another one is referring to a company. So in the attention mechanism, kind of address that limitation. In the attention mechanism, not only in using those words or distinguishing those words as a separate vector, but they're also memorizing the location of that particular word in that sentence. So here, Apple is more of like, here they're considering it in a different location and assigning a different vector weight to that. So in the computer vision world, in NLP world, we use the term called weightage. Like each word comes with a corresponding weightage. So these two words will be distinguished, differently based on their weightage. So that's the whole idea about this attention mechanism. That's not only helping the NLP, technique to go to the next level, but also it's kind of started paving the way for the large language model. Because before the advent of the attention mechanism transformer architecture, there is no way it was possible for the NLP foundation models to process the information or process as, document in a faster way and then provide summary. So that's kind of like, I would say, in the beginning of the, generative AI, and starting from this particular paper. Speaking of now the large language model. So like I said, like the transformer architecture, the paper kind of like, started paving the way for the large language model. So then when the large language model first started coming is that it was based on that attention mechanism. It started giving companies the idea that we have an attention transformer architecture. It can process longer sentences. It can process large corpus of text and stuff. Now, all we need to do is we need to start building models with millions or billions of parameters. And here the parameters are nothing but the amount of the data, the amount of the input text they're going to actually pass into the model, as well as, adjusting some model parameters. So if you see the journey of the large language model over here, you can see that it started from 2017. And as you can gradually go towards the right, you can see that the model parameter started increasing for most of the cases. Over here, I guess GPT-4, in this area, we actually got the ChatGPT. Because the ChatGPT was first launched in November 2022. So this is where actually, nearly the common people started knowing about GPT models and all kind of generative AI stuff. But if you see that, the chronology, you can see that the GPT model was there before. It was first launched actually back in 2018. But OpenAI, that time they just used this foundation model for research purpose. So they never decided to launch the product out of it until November 2022. But this particular, diagram is a really good, showing a good, a sequence of events happened in the development of a large language models. And it was only possible due to the advent of this transformer architecture. Now I'm going to take a pause to see if anybody has any questions, or is there any question that was, posted in the chat?
I have a question, Sam. We've heard a lot about hallucinations triggered by these generative LLM
Mhm,
models.
mhm.
Do you see the hallucinations as a problem that's transitory, given the rapid evolution of these powerful tools? Or do you see this as a persistent problem going forward?
That's a good question. I will definitely talk more about it in the later section. But hallucination is obviously like one of the key limitations of ALM models because it's mainly because the way that information has been processed in the large language model. And most of the cases, the information that we pass to the LLM models might not be accurate. It might be kind of like there's some misleading informations there, or the model architecture was not able to synthesize it properly. So my take here is it will definitely be a persistent problem. Probably we'll be able to alleviate that to some certain level in future that probably when all these GPT models started getting trained with more and more data, probably we'll be able to eradicate some of the hallucination issue, but it'll still be there. And I also wanted to, take it from like a human memory perspective. Like we process information, like we memorize things, but there are so many times we get to know, we get to have like a tend to have like a false memory. Like, if somebody asks me about something that happened 20 years back, I might not be able to provide an accurate answer. So I'm drawing that analogy because the model probably would have the similar kind of information where somebody passed a wrong information to an LLM model and it's going to get processed with that wrong information and provide not desired output, and that's caused that hallucination. So my theory here is that it will never be eradicated, but we can definitely minimize the impact of hallucination in future.
Thank you, Sam.
So speaking of that, the model gets trained more and more, and so this is kind of like the parameter strength of different GPT models. As we can see, that it started with 170 million parameters when OpenAI first launched their foundation model GPT-1, and GPT-2 they jumped from 170 million to 1.5 billion, and that was only possible because they started gaining access to some of the public repositories, and I'll share the details in the later section. So when the GPT-3 was launched, the ChatGPT was launched, the foundation model already had more than 175 billion parameters. I mean, that's like a tons of data we're talking about, probably for last 100 years data that they used to kind of like feed the model. So speaking of that, how did they get access to those huge volume of data? They mainly used, I guess, 2 or 3 different public repositories. That's what they, conveyed to the press, but we don't know the true story. They probably had some backdoor access to some other data. But based on the information shared by OpenAI, it seems like some of the, common repositories was Common Crawl, Book Corpus. These are some of the, public data repositories that OpenAI used to build their model. Recently, there's a new company called Hugging Face. They've been around for the last 5 to 6 years. They became very popular in the AI community because this Hugging Face is more of like, I would say, a GitHub, a kind of like a common platform where the AI engineers can go and they get access to the new models, data set, and all kind of stuff. So the reason actually I'm throwing out some of these names here, so in future, if somebody from this audience would be interested to take a look at the data, or they even want to do their own proof of concept work, I would definitely recommend to check out these 3 sites. Okay, so now I wanted to just touch upon a little bit about the advantages and limitations of large language model. There are obviously 5 terms that I wanted to emphasize here when it comes to large language models. Definitely, it's gonna give us extensibility and adaptability in the organization level, and give us more flexibility in terms of doing work that we never thought we would be able to do. Performance. Obviously, large language models can help the company in building some of the chatbots or some knowledge platform that can help the business leaders to get information in a more faster way. Ease of training, and the reason I'm mentioning that because now we do have those foundation models out there. So if somebody wants to kind of like build a model, for them, their work, all they need to do is, just give those foundation model and train that model with their own set of data. And fifth, five more, the last advantage is efficiency. And obviously having a large language model will kind of like give us like a PAM. It's more of like getting access to box of opportunities, it's, access to like so many things that we have never thought about. Now, if you go to social media, you've seen like every other day there's a new way AI companies or AI startups popping up. So that's kind of like it's opening a door of so many new ideas, sparking like thoughts that the AI community never thought about before. Some of the limitations, obviously, the development cost and operation cost. If somebody wants to start their startup company building upon something that generative AI already achieved, the main problem here is the development cost, since building those models, training them with the large data sets is expensive. We've seen that big tech companies now acquiring partnership with NVIDIA or AMD, all the semiconductors companies, so they can build their own supercomputers and stuff. So the cost is obviously a salient factor when it comes to building your own generative AI application and stuff. The next is bias and ethical concerns. I mean, this is a very prevailing factor right now, as it's also a very growing concerns that's shared by federal government, different institutes, and other stuff. We have seen that there are certain instances where the AI model started showing some sort of a discrimination to prevent demographic. Now the companies started hiring a lot of AI paralegals to ensure that the input data set that we are using for building generative AI models should be unbiased and should not showcase any ethical concerns. So that's one of the limitations that we need to keep in mind as we grow further and move further with generative AI models. Explainability, it's hard to explain. As you can see that I tried my best to probably explain about the generative AI and large language models in last 5 to 10 minutes, but it's really still a complex subject for everyone. Hallucination, as I just answered your question more, that hallucination will still be a persistent problem, but we would hope for elevating that to a certain extent as we started getting more accurate data and more ethical and unbiased data to train the model in future for occurrences. Complexity, obviously, it will be a complex topic for sure. That's why we need more trained AI engineers who can develop large language models or at least enhance a large language models for a business use case purpose. Okay, so that kind of brought me to the end of the natural language processing and the model case. Again, it's a fascinating subject. We can talk about that for hours and hours. There's tons of information out there that I would definitely encourage people to take a look at it. I'll definitely share this deck with you so you can have something for future reference, and if you want interest to drive more conversation regarding a large language model and generative AI, feel free to reach out to me. Now, our last topic is AI's role in image analytics. So this is also another very I would say like a foundation of AI, pillars of AI foundation, because the image analytics or computer vision kind of started around the same time when the NLP is also kind of going further. But here we had some sort of a concern in terms of availability of the data, because in the image analytics area, we are dealing with image data, and it was not something like we are kind of building a data set or getting a textual data from the repository. Well, so for the image analytics, the first thing first is that this image analytics is building upon the concept of analyzing and interpreting visual data. Like if you go to your bank website, now they're asking you to kind of probably set up a face ID. So how is this possible? So it's possible. The only way it was possible is that we have an AI model that's working in the back end that can scan your image and that can analyze your image, and next time when you try to utilize the same face ID, it can detect the pattern of your face, and that helps you to log into the site. So this kind of facial recognition was not possible before the advent of this image analytics. It also helped the medical imaging industry, especially the healthcare industry, as it's helping the healthcare professionals or that's local diagnostic platforms to get the help of AI to diagnose, perform the diagnosis in faster way. For example, there's so many companies are started building AI tools that's kind of like scanning the X-rays, the MRIs, and kind of doing a preliminary diagnosis check, and they're passing those information to the medical professional. There are a lot of healthcare professionals, they started kind of, tying up with those AI companies and helping them this kind of stuff. Obviously, the benefits here is that the accuracy and speed, having an AI model scanning through the images, giving you like a diagnosis result will expedite the process. But we also still have an ethical concern because most of the cases, the medical data, even the image data, is very much like data, I would say data security oriented. We need to make sure that we are having a proper HIPAA compliant and all kind of information stuff checked before we start using those kind of input data or imaging data for modeling purpose. Now, speaking of image analytics, I did a little bit of research on this particular subject, and 3 years back, I published a paper with an accordance of the University of Illinois Department in Deep Learning in Healthcare. So this paper was mainly oriented towards medical imaging on COVID X-ray. The research paper name is COVID-19 X-ray image classification using deep learning. The key concept here is that we built an AI model that will kind of help determining the COVID-19 cases from chest X-ray. Back in 2021, especially in the I would say like a low economic region or in the third world countries, they did not have availability of PCR centers in everywhere. The rapid testing of COVID-19 diagnosis was not possible in some areas. So back in those days, we came up with this research approach. We pitched it to our department that what if we will build a deep learning model that will help to detect COVID-19 from the chest X-ray image, because it's easier to kind of have X-ray and getting an X-ray done than RT-PCR in certain areas. So the main concept was to kind of like build an alternative of RT-PCR diagnosis system for detecting COVID-19. So in that particular research, we built an AI model from the scratch. We also use some of the foundation models to kind of use it as a baseline to compare the performance of our model with some of the foundation model. And the main impact was that it's more of like a faster and more accurate diagnostic. This research paper is already published in the MAID archive. I'll definitely share the link with the groups if anybody is interested to read out the research paper. Happy to share the link with them. And the main idea of this research was to mainly just build an alternative system for COVID-19 diagnosis. During this research, we built an AI model that can perform the image analytics. The main foundation of that image analytics, practice was that it will take an X-ray image as an input. It will check each and every pixel of the image. It will convert those pixels into their corresponding features. And I'm not going to go into this technicalities. This is more of like the deep learning architecture that we built as a part of the model building process, so that each and every pixel and their corresponding feature goes through those layers, the process, and go through like different kind of processing, and that each and every feature would construct prediction, and eventually those prediction will go into the final layer and predict that whether that particular X-ray image, of a COVID-19 or a pneumonia patient or a normal patient. And this is more of like, I would say like a basic image classification exercise built upon an image, chest X-ray imaging platform, chest imaging practice, sorry. So the main reason I wanted to share this, because this image analytics is still a quite evolving, field in the AI area. there's still a lot of researches are going on in terms of like developing more different kind of like computer vision in image analytics techniques. That if you've seen, so I think you are aware of some of the new cars, like a self-driven cars, or some of the new like an automated like a screening system coming up where they can automatically detect people based on their movement. Like the self-driven car is also a concept of like a computer vision or image analytics, where they have a bot that's kind of like behind that steering wheel, automatically detect a person, traffic signals, and all kind of stuff, and it's driving the car there. So the overall foundation is started from this CNN or neural network architecture, where the same model kind of like, taking those pictures or, real-time image as an input, processing it through the different layers of the architecture, model architecture, and then providing output based on image classification. And the classification will tell the model, okay, this is a chest, this is a COVID-19 patient image. We actually had an app built for that research after completion of the research. That app was out there a couple of years back, but we had to kind of take it down because of some monetary concerns, because this research was not funded. So that's why we never been able to kind of like, publish it in a reputed journal. I still receive email from some of the journals to publish the paper, but at this moment, we don't have any interest to publish it in future. But, if anybody is interested to know more about this work, feel free to reach out to me. We can definitely have a discussion. And I don't know if there'll be any use cases to build a patent out of it, because COVID-19 is still there, but I don't know it'll be very, I would say it's more of like a lucrative use case to build that app on top of it. So that project was, I would say, a very informative for me, at least, from image analytics standpoint, because this is the core foundation of the image analytics and medical imaging that continuously influencing the healthcare industry. There are more researches are going on to kind of like detect some of the I would say health condition in a more faster and accurate manner by just going through the medical imaging systems. Okay, I think that kind of like brings me to the final summary or final stage of this presentation. In this presentation, we talked about generative AI, we talked about large language models, we touched upon a little bit on image analytics and how advancement in NLP kind of like changed the paradigm of the whole AI, AI innovations strategy. What is the future trends in generative AI? Obviously, continuous improvement and showing some sort of ethical considerations. For example, like, as we know that some of the generative AI models already started showing some ethical issues, and it seems like they're biased, not, providing better, explanation or not providing better summary that users are looking for. So in those kind of ethical considerations, you need to keep in mind. And on top of that, we obviously have to address the hallucination issue in the future to see how we can get more accurate and precise information from the generative AI models. Final thoughts, AI is still a kind of quite evolving field of study. I mean, especially while we're going through the generative AI phase or generative AI era, this particular field of study will never go away. It will quite evolving in the future. There's a growing concern about how generative AI can influence the job market, as people are thinking that there will be a lot of job roles can be eliminated due to the advent of AI. So my thoughts here is, I mean, yes, obviously, the idea of AI is to augment human intelligence, not to replace it. But we can still see probably some roles can be eliminated in future. However, we can also see an emergence of some new roles. Just to give you an example, like the generative AI is capable of writing codes now. So who knows, in future, we might not need a software engineering roles in future. However, we will need a coding expert or those software engineers to accurately, assess the code that generative AI is providing us. So I don't see that there'll be any issue with, or there'll be kind of like a loss of jobs from generative AI perspective, but we need to continuously evolve and learn more about AI. So just to make sure that we can still keep up with the pace with this innovation, and we can still, know more about generative AI, so we can, still keep our jobs or do something that can influence the, the generative AI strategy for your organization.